arc length, and sector area. Now this is the radius, which is the half of the circle's complete diameter. Here we have a sector. And we also have an arc. Now with the blue marker, I'm showing a segment, as it doesn't go beyond the 2 points in between the circle. Now the question is how to calculate the arc length. Now the question is how to calculate the area of a sector. But if theta is in degrees, you can always use these formulas. Now here you can see examples of how to calculate arc length and area of a sector. Now we have the circle with center 0, 0 and with a point P which with coordinates x, y. Then its analysis is pretty simple. We just want to get the general equation for circles with center 0, 0, and this is the process to get it. The equation will be x squared plus y squared, which will equal r squared. But for unit circle, the general equation will be x squared plus y squared equals 1. Now here, if we analyze this graph by using the basics of trigonometry knowledge, which is SOHCAHTOA, we can see that we have a point P with coordinates A, B. So cos theta will equal A over 1, which will equal A. Sine theta will equal B over 1, which will equal B. And tan theta will equal sine theta over a cos theta. And so we can conclude that cos will be equal to the x-axis and y will be equal to the sine. So here we have the unit circle with the degrees measurements, and then as well with the radian measurements, the basic ones. Of course, you can keep dividing the circle and get more and more measurements. If you see 6 pi over pi will be equal to pi, and 7 pi over 6 will be somewhere around here. Now I'm going to show you a trick to do the triangles table. So it's pretty simple. You just write the main angles in degrees, 0, 30, 45, 60, 90. Then you write those angles in radians. Afterwards, you place a square root, a big one, and everything over 2. Then you get sine and you write down the numbers from 0 to 4. Then you get cosine and write down the numbers from 4 to 0. So if you want to get, let's say, sine of 45, you just will simply get the square root of 2 over 2. Or if you want to get cosine of pi over 6, you will simply get the square root of 3 over 2. And if you want to get 10, you just simply take the square root, but you don't divide. So for example, 10 of 90 degrees will be 4 divided 0 square root. That will be nothing. Now here we have the graph of sine x and cos x. Both have the amplitude of 1, so the maximum and minimum point it would be 1 and minimum minus 1. Both will have the period of 2 pi, and the sine graph will always start in 0, intersect the x-axis in pi and then in 2 pi, and the cosine will always start in the amplitude, then intersect the x-axis in 90, and then into 70 degrees. Now here we have the tan graph. The most important thing to know is that it has three asymptotes, minus pi over 2, pi over 2, 3 pi over 2, and that it intercepts the x-axis on 0 on pi. So now we're in transformation of graphs. This is the function for transforming any trigonometry graph. So first of all, we have A, which is equals the amplitude, which is maximum point minus minimum point over 2. Then we have the term B, which will be the period, so it would be 2 pi over B, the V value. Then we have minus C, which equals the horizontal shift. And then we have plus D, which will equal the vertical shift. Now I'm going to give you an example. So y will equal 3 sine 4x plus 2 pi plus 2. So it's pretty simple. 3 will be amplitude plus 2 will be the vertical shift. And so we have to find where the function is going to begin and where it's going to end. So you're going to take everything that is in the parentheses, so 4x plus 2 pi, and equal it to 0. There you will get the point of initiation where the function is going to start. And now to get the final point where the function is going to end, you have to equal what is in the parentheses to 2 pi. Now you just need to plot all the information you got before, so starting with the vertical shape and then again on the amplitude, and according to this vertical shape that will be your new x-axis, then get the initiation point, the final point, and graph your regular sine function. When you have trig equations, you will always like to find sine times a variable, which will equal a value or a number. How? So there are four things you can do. The first one is by clearing out, the second one is by factorizing, the third one is by quadratics, and the fourth one is with identities. Now, example with clearing out. Now, example with the method of factorizing. An example with quadratics. Now, trigonometric identities. These are the basic ones. You should know them and know how to apply them. Now, an example using them or using one of them. This would be using the first one. As part of the trigonometric identities, we also have the double angle formulas. You should know them all, or otherwise you will find them on your formula sheet. Now here is an example using the first double angle formula shown.